Hi y'all, this is the video review for your fall semester final. So the review is very similar to the test. If you are comfortable doing the review, then you will get a great grade on your test. Your test is 25 multiple choice questions. So if you are not having all the time in the world to do this review, which I know that you have a lot of other finals to study for as well, if you look at the question and you feel like you're comfortable with it, then don't do the question. I'm not going to take the review as a grade, so don't waste your time trying to strengthen a skill that you're already really good at. Focus more on the things that you are having trouble with. So like, for example, number 2, if you're like, I'm good at graph symmetry, then don't do that question. But number 1, you're like, I have no idea what that's even asking, then you need to spend more time focusing on that question, okay? So prioritize your time as you're going through the review. So let's get started. Number 1 wants you to find f of g of x, so this, given f of x and g of x. So this is called composition of functions, and it's like putting one function inside of another. So f of g of x means that your outer function f is going to have the letter x that's replaced in it with this entire g of x. So your original f of x is the 1 over 3x plus 2. When I find f of g of x, I'm going to replace this x with this entire g of x here. So the 1/3 is going to stay. My x is going to be replaced with x plus 5, and then the plus 2 is going to stay. So that's your setup. Then you're going to distribute the 1/3 to whatever's in parentheses. 1/3 times x, and then 1/3 times 5 is 5 over 3 plus 2. So this is almost simplified. You can combine that 5 over 3 and the 2 that's there. You can either do this in your calculator or you can do it by hand. In case you're wondering how to do it by hand, you have to find a common denominator of 3. So what divided by 3 gives me 2, 6. Add across the top, 5 plus 6 is 11. So you get 1/3 x plus 11 over, I don't know why I just drew a pi, plus 11 over 3, and that is your final answer. Okay, number 2, what type of symmetry does this graph have? So your 3 different options for graph symmetry are x-axis, y-axis, and origin. You're looking for what line can I cut this in half about and it look the same on both sides. So if I cut this graph in half along the y-axis, it looks identical on this side and on this side. So this graph has y-axis symmetry. Okay. Number 3, what are the vertical asymptotes? So you're more looking for a location of where vertical asymptotes would be. The vertical asymptotes are located on the bottom of the fraction, but it is not the matching factor. So this right here, this is a vertical asymptote. I'm going to go through and label them so we don't get confused. This is a vertical asymptote. The 2 would be a horizontal asymptote. This would represent a root. And then these, the x plus 3s, since they are the same, you would be able to cancel those out. So those would be a whole or a removable discontinuity. So the x plus 2 is going to help us find the vertical asymptote. And that factor, that x plus 2, to figure out where the vertical asymptote actually is, you're going to set that equal to 0, and then you're going to solve for x, or just think about it as flipping the sign of whatever's there. So x equals -2 would be your vertical asymptote there. So just find the factor and then flip the sign. Okay, the next one, where is the removable discontinuity? A removable discontinuity means a hole It's just the factor that you can cancel out. So looking here, I'm looking for the factor that's identical on the top and the bottom. You have this x plus 3 and this x plus 3. So that means the removable discontinuity, or the whole, is at x plus 3. And just like I did on the last problem, I'm going to set this equal to 0 to solve for x. Or you can think about it as flipping the sign of the factor that's there. So x equals -3 is the removable discontinuity. In prior tests, I've asked you to find the point, but on the final, I'm just going to ask you to find the x value of that point like I did here. Okay, number 5, what are the transformations that are applied to this function? So transformations are things like moving up, down, left, right, vertical stretch, vertical shrink, horizontal stretch, horizontal shrink, and so on. Okay, so these conditions, as you're making your note card, would be a great thing to put on there. I'm not going to provide you the rules for transformations, so if you feel like you can't remember those, writing the rules for transformations would be a great thing to put on your note card. Okay, so the 1/2 that's in the front, this is an a value, and 1/2 is smaller than 1. So this is going to cause my graph to have a vertical compression. Whenever the number in the front of the function is smaller than 1, or a fraction where the top number is smaller than the bottom number, that means you have a vertical compression. The 3 that's here, this is a b value. That b value of 3 is bigger than 1. This has the opposite conditions of vertical changes. So if the b value is bigger than 1, that means you have a horizontal compression. And I always, when I'm talking about horizontal transformations, I stretch or compress by 1 over b. So if my b value here is 3, that means I have a horizontal compression of 1 over 3. Here I would have a vertical compression of 1/2. Okay, the -1, remember x lies, so it always moves in the opposite direction. So this is actually going to move our graph to the right one. And then the +2, that's in the back, so that's going to move us up or down. So I'm going to go up 2. That one works the way that you would think it would, with the addition and subtraction symbol. Okay, so put those rules on your note card if you feel like you can't remember those. Okay, number 6, I'm given a polynomial, and I want to write the end behavior of that given function. So what I'm looking for end behavior, I'm going to pay attention to the number in the front. That is called my a value, or my leading coefficient. It's going to abbreviate coefficient. It's 4. 4 is a positive number. And then I'm going to look at my exponent. That is my degree. If my degree is 6, that's an even number. So the words that I'm going to pay attention to here are positive and even. So a even graph, or an even polynomial, has both ends of the graph pointing in the same direction. So I know that they're either going to both be going up or both be going down. The fact that the leading coefficient is positive means that they are both going to be going up. So the ends of my graph are going to look something like this. The notation that we're going to use involves infinity symbols. So if you're going to the right or you're going upwards, that goes towards positive infinity. If you're going to the left or you're going down, that takes you to negative infinity. Okay, so I'm going to say as x approaches infinity. So, ooh, that's ugly. Okay, as x approaches infinity, so I'm going in this direction. My y value is going up. So as x goes to infinity, this function is named g of x. So I'm going to say g of x goes towards infinity. As x goes towards negative infinity, so now I'm looking in this direction, g of x also goes towards positive infinity. So the way that you write out end behavior always starts with as x goes to infinity, g of x goes to blank, and as x goes to negative infinity, g of x goes to blank. So the two things that I've underlined there are always going to stay the same. What's going to change is what I've underlined here in blue, and that changes depending on what type of function you're given. Okay, number 7. This is a very calculator-based question. You're given a function, and you want to figure out the concentration of medication in a patient's blood, and T stands for the number of hours. So if I ask you to find C of 2, I'm asking you to find the amount of, or the concentration of medication in a patient's bloodstream after 2 hours. So what you're going to do on your Inspire, your calculator, is you're going to graph this, but when you graph it, make sure that you have your, don't enter the variable T. You're going to enter it with an X. So you're going to put 60x, x squared plus 30. That's what you're going to put into the calculator. After you graph it, you're going to press Control T, and you're going to scroll to where the x value is equal to 2. The y value that goes with that point is the answer. So the y value that goes with that point, if you look at your calculator, is 3.529. So C of 2 is equal to 3.529. So this is also something, if you feel like you're not going to remember those calculator steps, write that down on your note card. Okay, number 8. This is probably the most difficult question on the test. This is a piecewise. We all struggle with piecewise. This is something that your calculator, I do not think, is able to graph piecewise functions. So you're probably going to have to do a little bit of thinking outside of the calculator. What you're going to be paying attention to is this portion here. You're looking at those domain restrictions, because this is asking you what is the domain of the piecewise function, and we're going to be listing that in interval notation. So my domain goes from the smallest number to the largest number, and I'm going to be paying attention to the inequality symbols. Remember, if you have something like this, this goes with a bracket, and if you have something like this, this goes with a parentheses. So I'm going to start with the smallest number that I've boxed in red. The smallest number that is there is -5. The symbol attached to -5 does not have a line underneath of it. So my domain is going to start with a parenthesis, and I'm going to go -5, comma. Now I'm going to look for the next smallest number. The next smallest number is 0. But if you look at between the -5 and the 3, 0 is already in between -5 and 3. So I'm not going to have a break in my graph at 0, since it is already included in that first domain of -5 to 3. So I'm not going to put a 0 after the comma. I'm going to look for the next smallest number, the next smallest or the next largest number. So we went -5, 0, but 0 is already included. The next number is 3. 3 is not included in a previous domain. So my graph is going to have a break at 3, and I'm going to, since this symbol has a line underneath of it, I'm going to put a bracket around that. And then my my domain is going to jump. I'm going to have like an area in my graph that doesn't have, it's not defined. So you're going to put a a union symbol, and I'm going to go bracket 3 because it's included to 4. And the 4 is going to get a parenthesis. I'm going to draw a quick sketch here. I'm not very good at drawing lines, as you can tell. Okay, so if you're able to graph this, it's kind of tricky to graph it, but if you're able to graph this, you're looking at the y-intercept and the slopes of what are given up here. So if you want to draw yourself a picture, you can. You're just going to graph the line, how you would graph a line using the y-intercept and the slope, and you're just going to restrict it between the boundaries that it gives you. So I'm looking, domain looks from left to right. So if I'm looking on the leftmost point, the leftmost point in my domain is -5. But notice that it's an open circle. So that's why on our domain, our -5 has that parenthesis that's there. Then as I'm scanning, the next x value that I get to, or that I would have an issue with, is right here. But notice that you have a closed circle there and this part of the graph exists. So I'm not going to have a problem at that point. It's just the start of another line, another piece, but there's no issues at that value. The next value I get to is 3, and 3 is defined because I have a closed circle there, so that's why we've got the bracket around the 3. And then my graph kind of jumps from 3 to 4. And at 4, you have an open circle, so that's why we have that parenthesis there around the number 4. Remember, this is multiple choice, so if you are very confused about the question, if you sketch a picture and then compare the multiple choice answers, you can say, oh, this looks right, or no, this doesn't make any sense, okay? But usually piecewise functions are going to have a union symbol in between, so look for that in your answer choice. Okay, number 9, what is the degree of the graph shown? So the degree, the rule, this is also something that you might want to put on your note card. The degree is the number of turning points plus 1. So turning points are highs and lows. So I've got 1, 2, 3, 4. So if my turning points are 4, I'm going to add 1 to that and get 5. So this would be a degree 5. And to double check yourself, a degree 5 is an odd degree. Odd degree polynomials are pointing in different directions. This polynomial, one end is going down, one end is going up. So we know that this is odd, so our degree is good to go. Okay? Number 10, is the leading coefficient, the a value of the graph above, positive or negative? So if it's positive, that means that the right end of the graph is facing up. If you look here, the right end of our graph is facing up, so our leading coefficient here is positive. Okay, number 11, converting to radians. A lot of us on that test, on that trig test, the first one, had a lot of issues converting between degrees and radians or radians and degrees. So you need to write down the rules for converting on your note card. So convert 250 degrees to radians. If I'm going from degree to radians, I'm going to multiply by pi over 180 degrees. If I was going from radians to degrees, I would need to multiply by 180 degrees over pi. But in this case, I'm going from degrees to radians. So I'm going to take my 250 degrees and I'm going to multiply it by pi over 180 degrees. So now these degree symbols cancel and I multiply these two together. So I get 250 pi over 180 pi, or just 180, sorry. Really the only thing I can do to reduce that is turn it into 25 pi over 18, and that would be your measurement in radians. So on your test, it will ask you to give it in pi. Please do not type this into the calculator and then get some random decimal. I want it to have the pi in there, okay? Okay, number 12, find a positive and a negative coterminal, so our keyword is coterminal, angle to 400 degrees. Coterminal means that you can either add 360 or you can subtract 360 as many times as you want to. So if I want to find a positive coterminal angle here, I can take my original angle of 400 degrees and I can add 360 degrees to it, and it gives me 760 degrees. So that would be fine. For the negative coterminal, I'm going to take my 400 degrees and subtract 360. When I do that, I get 40 degrees. That number of 40 is still positive. It wants a negative number. So I'm going to subtract 360 degrees again and get negative 320 degrees, and that's a negative number. So that's my negative coterminal angle. Okay, number 13. What is the x scale for the following trig equation? The formula for x scale, another great thing that you might want to put on your note card, is pi over 2 divided by b. So my b value is whatever number is in front of the parentheses, so that pi over 5 is my b value. So I have pi over 2 divided by pi over 5. Whenever you're dividing by a fraction, remember that you're going to multiply by the reciprocal. So this is pi over 2 times 5 over pi. Now the pi's are going to cancel, and you're going to be left with 5 over 2, and that 5 over 2 is our x scale. Okay, I'm going to stop this video here. This is part 1. I'm just doing this for the purposes of not giving you a 30-minute video. So part 2 will be posted shortly after this one, but you're going to have to click out of this and then go into part 2 of the video to get the rest of the review.